Hello guys, welcome back to my YouTube channel. Today I'm going to explain about heap concept in the data structure. So this is a very important in the advanced level of the data structures. First of all, let's see the what is heap. Heap is a one special type of binary tree. So binary tree is nothing but the representation of the binary tree is nodes. So we can use nodes here to represent the binary tree. For that, there is a nodes. One is root node. The first one is we call it as a root node, and this left one we call it as a children's. This below nodes we call it as a children's, left child and right child. So in the same way, heap also is a special type of binary tree. So in this heap there is a two properties, that is maximum heap, another one is minimum heap. In the maximum heap, the root element value is greater than its children's, means the root element at every time the root element will be higher than its child. For example, let's take 30, 10 and 20. So this is a maximum heap. So because the root element is 30 higher than its child, because 10 is less than 30 and 20 is less than 30. So if you take like this 20 and 30 and 40, this is not a maximum heap. This one we call it as a minimum heap. Minimum heap nothing but the root is always smaller than the children's. These are the children's. So this is the root. This is we call it as a minimum heap. So these are the basic things in the heap concept. Heap is nothing but it is a special type of binary tree, and also in this heap there is a two concepts, maximum heaps and minimum heaps. The maximum heap is nothing but the root element is bigger than its children. So the minimum heap is nothing but the root element is smaller than every time it's smaller than its children. And one more thing, heap is also complete binary tree. Means binary tree means in all levels in the tree, all levels are filled except the last level, which fills from left to right. For example, let's take here I'm taking 30, 10, 25 and 4. This is complete binary tree in all level filled except the last level. Suppose let us take 30 and 10, 20, 25, 24. It is not a complete binary tree because each level it should fill, and also it fill from left to right. There is no elements is there. So that's why this is not a complete binary tree. So this is complete binary tree. So it will fill the all levels except last level, and also it will from left to right. And there is a concept in this, we are using the trees concept, but trees are represented with nodes. So if we represent this heap with these nodes, so we need this left pointer and the right pointer. Pointers we need. So for this we need memory more, and also find an array, that binary tree. So it will take time also. So to solve these things we use arrays. First, arrays are represented with indexes 0, 1, 2, 3, 4. With the help of this array, we can easily find in which index what value is there, and also we can find the left elements and right elements of the rows in some mathematical calculations. For that, there is a three formulas is there. Find the root element of the element. So we use I by 2 formula, and also to find the left element we use left children I into 2, for the right children I into 2 plus 1. Let's discuss these problems. These formulas. For example, I am taking an array 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4. Let's find it out. In the heap, the array indexes starts from 1 and 5. Let's find it out. To find the root, we use I by 2 formula. For example, there is an element like 2 is there. So for this 2, what is the root element? For that, so what is the index of the second element? Index is 2 by 2 is equals to 2 by 2 is 1. So first index. So this index element is the root element of this 2. And another one is, so what is the left element of 2? What is the left element of 2? For that, I is equals to 2. I into 2 is equals to 2 into 2, 4. Fourth index. This fourth index, 4 is the left child of this 2. And another one is, what is the right child of the 2? Right child of the 2. For that, I into 2 plus 1. This is an formula for that. So 2 into 2 plus 1. 2 into 2, 4 plus 1. That is 5. So 5 is the right child of the 2. And let's take one more example, and then you can understand. So this already I told you, this is complete binary tree. For that, 1, V, 3, 3. Here I have taken the one binary tree. So this is a complete binary tree. because all levels are filled. And reading of this, so representation of this binary tree into arrays, that is simple. So just read the levels only. A is a one level, B C as a one level, B and C as a one level, D and is one level. This is one index, second index, third index, fourth index, fifth index. Now you can understand. See, what is the root of this B? For that, what is the formula for that? I by 2. 2 by 2 is 1. First index is the root element. So A is the root element of B. And what is the left child of B? 2 into 2. That is 4. So D is the left child of B. And what is the right child of B? 2 into 2 plus 1. That is 5. So E is the right child of the B. I hope you understood this heap and what is maximum heap, minimum heap, and how what is the representation of a complete binary tree, and how to represent binary tree and mean complete binary tree into arrays.